Cather Simpson, and I'm the director of the Photon Factory. Now, the Photon Factory is a laser lab, and a laser is just a way to make specific kinds of light. Okay, so what we study in the Photon Factory is how laser light interacts with molecules. And the reason that we're interested in that is that light is a form of energy. And so when a molecule, like the molecule on the back of your eye or the molecule in a leaf of a plant, absorbs light, what it does is it absorbs that light and converts it into a different form of energy. So it takes light from the sun or from the lights in the room, and on the back of your eye, it turns that light into a mechanical motion, and that motion then gets turned into a nerve signal that says, ooh, I just saw something. In a plant, the light hits the leaf on the plant, and it gets absorbed, and then it gets turned into a charge separation. So it's like a little bitty molecular battery. And the research that we do in my lab is to use very high-tech lasers, which are just exotic ways to make and control light, to study how molecules decide what they're going to do when they absorb that energy. So I became a scientist originally because I thought learning new knowledge was really cool. It's just exciting. You're curious about something, and science lets you figure out how to answer questions. So in science, you don't answer the question why, you answer the question how, and I found that really rewarding. It's kind of like doing Sudoku puzzles for a living. I would say that I became a scientist because of the curiosity-driven, satisfy that need to solve puzzles and things side of my personality. But I stay a scientist because I've learned over the years that the stuff that we learn in the lab actually has a positive impact on real people, on civilization. So here in the Photon Factory, what we do is we take the basic knowledge that we learn about how molecules interact with light, how they absorb that light and turn it into a different form of energy, and we use that knowledge to come up with new ways to solve problems for society. For example, we have a project with a company in the United States that's looking at how to use lasers to do bone surgery. That's really rewarding. Something that we learn here in the lab with all of these lasers might actually help someone who has, say, a chronic sinus infection heal better. We also apply our technology to things like the agriculture industry. So one of our devices that we've made, and we've made this using our lasers and using the basic physics that we know, this device right here is a way to sort sperm for the dairy industry. If you're a dairy farmer, you want cows, girls, and you don't want that many bulls. You don't want that many male offspring. And it turns out that you can have a huge impact on your success in the dairy industry if you can do that selection better. So the basic science that we do here with our lasers actually can have an impact on the economy and also on human health and human well-being. And that makes me feel really good. And that's why I stay being a scientist. So all of those challenges that we're facing, global climate change, clean drinking water, clean energy, all of those things are things that scientists, those challenges are challenges that scientists are going to solve. And the scientists that are going to solve them are sitting in primary school classrooms right now. They're 8, 9, 10, 11, 12 years old. We're on our way, but it's those students, those children who have enthusiasm and creativity and natural problem-solving abilities, they're going to be the ones that come along and transform our society. They're going to figure out ways to make clean drinking water for China and India and all of the other people that are coming onto our planet. They're going to figure out ways to make sustainable energy so that we can go where we want to go and live how we want to live without polluting our environment.